All right, so in these video notes, we are starting chemical bonding. And so, what is a chemical bond? It is an attraction between two atoms to form a chemical compound in some way. And so, there's two main types of bonding that we're going to learn in this unit. One is ionic bonding, and the other one is covalent bonding. So, we're going to start focusing on ionic bonding this week. And so, there is a space for you to write the essential question for the notes we're getting ready to take. So at the where it says EQ, please write down that you are going to figure out how an atom can become an ion, because ions are what forms ionic bonds. So ionic bonding, electron transfer. So first of all, there is something called this octet rule, which we've kind of talked about before, and it's when atoms really want to have 8 valence electrons on their outer orbit or shell to become stable. Now there's an exception. Hydrogen and helium are an exception, and they only need 2 total. And so they aren't going to do the 8, but all the other atoms want 8. So in ionic bonding and ions, some atoms will give electrons to other atoms, and some electrons will take atoms to get and obtain the number 8. And when they get the number 8, then a chemical bond can form. So when atoms give or take electrons, that is when they become an ion. So either getting an electron or taking an electron, they can turn into an ion or become an ion. So what is an ion? An ion is an atom with a positive or a negative charge. So if an atom is a positive ion, that means it has a positive charge where an atom has lost a valence electron or several valence electrons. And so you basically lose negativity because you're giving up electrons. Remember, electrons are negative. So if you lose negativity, if you lose the electrons, you're going to lose the negativity. And if you are a negative ion, you will have a negative charge because negative ions gain electrons. So if you gain more electrons, you're gaining more negativity because electrons are negative. So if you gain more electrons, you're going to become more negative because you're getting more negativity. Positive ions and negative ions attract each other, and that attraction is what bonds the two ions together, because it's like opposites attract. Positives attract to negatives, and so that's kind of where the ionic bond is coming from those attraction of charges from the losing and gaining of the electrons. So remember, if you lose a negative electron, you become positive. If you gain an electron, you become more negative. So there is, remember the valence electron number we put on a periodic table. So remember the alkaline metal group has 1 valence electron on its outer shell. The alkaline earth metals, they have 2 valence electrons. And then if you come over to the other side, it's 3, 4, 5, 6. Remember, halogens have 7, and noble gases are most stable because they have that 8. So because they have 8, they don't want to bond with anything else because they have that stable 8. And that's why they're so unreactive and stable gas molecules. All right, so we're going to practice the Lewis dot structure with sodium and chlorine and how they become ions together and want to bond. So I want you to draw this as we go through it. So sodium, if you look on the periodic table, sodium is right here, and it is in an alkaline metal, so it's going to have 1 valence electron. So you put 1 dot. You could put the dot on the side and the top, the bottom, but you just put 1 dot. And then chlorine, if you look at chlorine is over here. Chlorine is a halogen. And so halogen is in 7. So that means it has 7 valence electrons on its outer shell. So you would draw 7 dots. Now you would draw 1 dot on top, left, bottom, and right. And then you would continue until there's 7 dots. So it kind of looks like this. So 1 is empty. So what happens is sodium is going to give its electron to chlorine, and then because sodium gave the electron, it's going to be positive, and chlorine, because it gained an electron, it'll be negative. And then so that's what it looks like. So after you ask the questions, did sodium gain or lose an electron? Well, it lost an electron. So because it lost an electron, it lost some of its negativity, so it's going to become positive. And did chlorine gain or lose an electron? It gained an electron. So that means that chlorine was or had a more negative charge. And those two together, those charges, attract. And that forms sodium chloride, which is your table salt. Okay, so how do you know which ion will form? There's kind of like a cheat way, essentially, to think of it. So if you are an atom that has less than 4 electrons on your outer shell, then you'll lose electrons. And because you're losing electrons, you're losing that negativity, so you'll become more positive. And metals tend to want to lose electrons. Now, if you have more than 4 valence electrons, you are going to tend to want to get electrons. It's easier to gain 2 than to lose 6. So they become more negative because they're gaining. Remember, they're gaining that more more negative electrons, so they become more negative. And nonmetals tend to gain electrons more. And so these metals and nonmetals tend to form compounds through ionic bonding together. All right, so let's continue reviewing. So if you were to look at your periodic table and guess before I give you the answer, magnesium, how many electrons would magnesium lose or gain electrons? And then what would its charge be, positive or negative? So if you could look at magnesium, you can see the outer orbit has 2 electrons. So is it going to gain or lose? It's going to lose 2 electrons, and because it's losing 2 electrons, it's going to become positive. Okay, let's look at boron. Boron has 3 valence electrons. Boron has 3 valence electrons on its outer orbit, and so because boron has 3, remember, less than 4, will lose. So it will lose 3 and it will become a positive charge. Now if you look at sulfur, sulfur has 6, 2, 4, 6. 6 valence electrons. So like I said, it's easier to gain 2 than lose all 6. So actually sulfur is going to gain 2 electrons, and because it's gaining a negative electrons, it's going to have more negative charge. And then if you look at nitrogen, nitrogen has 2, 3, 4, 5. So it's more than 5 or more than 4. So they're also going to gain. So we're going to take a moment, pause the video, and look and see how many electrons lithium, sodium, aluminum, fluorine, calcium, and nitrogen, and pause and decide whether they're going to gain or lose electrons. All right, so I'd like you to go to page 5 in your packet, and I want us to practice this Lewis dot structure again and try and figure out where the electrons are going to go. So we're just going to practice the Lewis dot structure. There is formula and name below it. We're going to not worry about that right now. We're just going to worry about the top part. So number 1 on page 5 says, show the Lewis dot structure and what would happen to the electrons with sodium and chlorine. So you got to look at your periodic table, and so you got to find where sodium is. So sodium is right here, and you got to find where chlorine is, which is right here. And so you write Na for the symbol for sodium and Cl for chlorine, and then you need to make the dot structure. So sodium, again, is an alkaline metal, so it only has 1 valence electron, so you put 1 dot. Chlorine is a halogen, so it has 7 valence electrons. So remember, you start with 1 in each side, and then you begin to fill in the second. So you go 1, 2, 3, okay, and then there's 7. So then I want you to show me, okay, what's going to happen to the electrons. So the sodium is going to actually give the electron to chlorine, like we've shown before. So that's the example for number 1. So in number 2, it wants you to do the dot structure for potassium and iodine. So we have to find potassium, which is right here on the periodic table, and we have to find iodine, which is right here. So again, potassium is an alkaline metal, so it has 1 valence electron on its outer shell. Iodine is a halogen, and so it's going to have 7. So again, you fill in 1 in each first. Get in the habit of doing that so you're putting the dot structure correctly. Oops. And then you should show an arrow. So it's easier to lose an electron than to gain 7. So potassium is going to give its electron to iodine. All right, number 3, magnesium and oxygen. So magnesium actually is an alkaline earth metal. It has 2 valence electrons. So you would do maybe 1 here and 1 there. Oxygen is a nonmetal, and it is not a halogen or noble gas. So it's here, and they actually have 6. Oxygen, if you look at the periodic table, has 6 valence electrons. So you do 4 around. Okay, and then you would start again to get to 6. All right, so like we've said, metals usually tend to lose electrons. So magnesium is going to give both of its electrons to oxygen, and then you'll see a complete 8. All right, I would like you to finish pages 5 and 6 by doing questions 4 through 12. And remember, don't worry about the formula and name at this point. We will worry about that in class this week.